So let's set the stage here. We're at a conference about performance, with performance being the manner in which a mechanism behaves. I was conducting some accessibility auditing last year, which is the process of performing manual and automated checks to see if a website can work with assistive technology. The client was a medical education app, and it was used to train caregivers before they go out into the real world. And it was built using a single-page application framework using Google's material design library to build the user interface. When I learned that, I thought, Google made it. Oh, sweet, I don't have to worry as much. So I fire up VoiceOver, which is macOS's screen reader, and start my testing, and things are going pretty well. And then VoiceOver crashes. So I try restarting Safari, I try clearing the cache, I tried closing other tabs, I even try rebooting, I use computers. Same result every time. So I ask my boss what's going on, and he says, oh, it's probably problems with the accessibility tree. I'm like, the what now? So before I get more into this, here's a question for y'all. How do you describe an interface? I'm not saying tell me what you see and what you hear when you turn on a computer on. I'm saying how do you speak computer to computer? The way we can do this is via the accessibility tree. Fundamentally, it is a collection of objects, which are all the little atomic bits that make up a user interface. People who rely on the accessibility tree do so using assistive technology, and they do this to navigate and take action on user interfaces. Without a functioning accessibility tree, there is no way to describe what the current state of an interface is, and consequently, no way for some people to be able to use a computer or a smartphone. So, suffice to say, this is a really important piece of technology. So how do you build one? First, you have to give each individual object in an interface a name. Names are short identifiers used to describe purpose. Then you give it a role. Roles are predefined values that tell someone what they can do to an interface object. For example, a role of button means you can press it to activate some sort of predefined action. Then we have properties, which are the attributes of the object. Examples of this are its position in an interface, its state, or interactions that are allowed. For our button example, that could mean a press state to signify that it has been clicked on. And then finally, we have a description, which can provide further information about the object if needed. And these accessible objects are then programmatically grouped together to form more complicated interface components. So how do you build interface components? Let's say we have a operating system alert dialog. That's a pretty commonplace thing for UI. Starting from the top down, we have a menu bar, and that's the anchor that we're going to attach everything to. And then we add a title for the menu bar so we know what it's all about and what contents we can expect to find. If you're using a screen reader, titles are really helpful because it saves you from having to dig into the interface component to figure out what's going on and what it contains. We might also need to close this dialog window once we learn what it's for, so we include a close button in the menu bar. Then we add the bulk of the dialog, the place where we can place all of our content. In the body, there's another title which asks us if we want to save the changes to the thing that we were working on. And then text to the body that will provide a little bit more information about the consequences if you choose not to save. Then we add a save button to allow us to commit to saving the changes that we made, and a cancel button in case we don't. And presto, we have a dialog component. Because these collected objects all have accessible names and are therefore present in the accessibility tree, we can speak computer to get what we want. I can programmatically say, go to the dialog, then its body, and activate the save button, and it works. How cool is that? And so this might seem a little pedantic, but please bear with me for a bit. This is a polar bear from the show Polar Bear Cafe, which is adorable if you are so inclined. So we do have this dialog component, but there's more to it than just that. Interface components have to have a place to live, and that place is in an operating system. Operating systems also include components that allow us to navigate to and access the stuff you store on them. It also is the place where we install and run programs and all the little doodads and widgets we can't live without. And the browser, which is rapidly becoming an operating system in its own right. And the browser contains the mechanisms that we use to access the web. And the web is sort of like the Wild West in that you can write more or less whatever you want, and it'll usually work, which is both a blessing and a curse. But regardless of how you write what you write, you can't escape the fact that you ultimately create HTML. That HTML then has its appearance and behavior augmented by both JavaScript and CSS. And again, there's many ways to go about doing this, but they are the other two requisite parts that make up the whole that is a modern website or web app. This HTML markup, augmented by JavaScript and CSS, creates the document object model, or DOM tree, which is a programming interface for websites. And then browsers read the DOM and all the information contained within it to draw a visual interface, which is then shown to the user, which is you. The user can then take actions, which updates the DOM, which in turn updates what is visually rendered. This allows us to make our websites dynamic. And then running in parallel to this is the accessibility tree, which is sampled from the generated DOM. I say sampled because the accessibility tree will use specialized heuristics to only surface things it deems necessary. Modern versions of the accessibility tree are generated after styles are computed, as certain CSS properties such as display and pseudo-element content will affect it. This sampled version of the DOM is then read by various kinds of assistive technologies, including but not limited to screen readers. And there's two very important things I'd like to point out here. First, usually using a visually rendered interface and assistive technology aren't mutually exclusive. Not all screen reader users are blind, and many people choose to augment their visual browsing with devices that rely on the accessibility tree. Secondly, the accessibility tree relies on the user interfacing with the DOM to update. It's effectively a read-only technology in that we can't work directly with it. And another thing you should be aware of is it's more of an accessibility forest than it is an accessibility tree. There are many different implementations of the accessibility tree, and each depends on the operating system you're using and said version of that operating system. And this is due to the different ways companies have built and updated their underlying source code throughout the years. And just so we're clear, the DOM can be a part of the accessibility tree, but the accessibility tree is larger and not just limited to the contents of your browser. Because of this, the accessibility tree is more brittle. It has more to pay attention to, and its technical architecture was developed before this whole internet thing really took off, meaning it didn't anticipate the sheer amount of information we'd be throwing at it. Crashing the accessibility tree and therefore breaking assistive tech support is bad, yes. But a large amount of information present in the DOM means that there's an accompanying large amount of work the accessibility tree needs to do to figure out what's what and report on it, which slows it down. This can create a lack of synchronization between the current state of the page and what is being reported by assistive tech, meaning that a user may not be working with an accurate model of the current screen and may be taking action on interactive components that are no longer present. And this can create the confusing experience of activating the wrong control or navigating to a place they didn't intend to. So how do we help prevent this? You start with writing semantic HTML. Using things like the button element for buttons instead of aria slapped onto a div helps lessen the amount of guesswork the accessibility tree has to do. And when it runs its heuristics to slot meaningful content into its description of the current state of things, this goes a long way. This serves to both speed up its calculation and also makes what it reports more reliable. And speaking of semantic HTML, here's the raw living DOM tree of an actual website. In fact, it's the website for this conference. Estelle, I'm sorry but not sorry. Even in a static performant website, contains a lot of information a computer has to chew through. And again, utilizing semantic HTML makes the markup present here, Again, utilizing the semantic HTML, like the markup present here, helps reduce the effort it takes to generate the accessibility tree. And unfortunately, using semantic HTML is kind of a rare thing these days, which is partly why I'm here giving this talk. And all right, I think you get the gist of it. Of the code I just showed you, 5 slides worth, we've only covered the top quarter of just the home page. Again, this is a lot of stuff to process. And so keeping this DOM tree example in mind, we now have a simple form. It's a pair of unstyled radio buttons asking you if you want the chicken or the fish as your meal preference. Here's how that form might be translated into the accessibility tree. If we use semantic HTML, the names, roles, and properties are automatically mapped for us without having to spend any additional effort. And when I was speaking more about how semantic HTML slots in, this is what I'm getting at. Here's a slightly more high-fidelity example, sampled again from the Perf Matters homepage. I'm using Firefox's accessibility inspector to dig into a link, a humble, simple link. There's a ton of information exposed here, including attributes, states, actions, a child element count, relations, and available actions. All of this data is used by the accessibility tree to help it describe the shape of things. And here's an even more high-fidelity example. This is a raw text dump of the accessibility tree for this same page. This is an example of what the language might look like when we're speaking machine directly to machine. We don't speak machine directly, though. Before we had Firefox's accessibility inspector, we had to rely on more specialized tools to be the translators. The Paciello Group's A-Viewer and Apple's accessibility inspector are the two go-to resources here. And you're still going to need them if you want to inspect anything that isn't a website, or if you want to do some really serious digging. Pro tip, you don't really usually need to do really serious digging. So let's make the abstract immediate here. What's going on here, and why should you care? With my auditing project, I narrowed the problem down to issues with the material design's radio inputs. This is how they appear visually, and here's how they appear in code. To make a material design radio input, you need 6 HTML elements containing 9 attributes with a DOM depth of 3. You also need 66 CSS selectors containing 141 properties, which weighs in at 10K when minified. You will also need 2,374 lines of JavaScript, which weighs in at 30K when minified. All this gets us a radio input. But you need more than one radio input to be able to use it properly, and oftentimes there's a few options to select from. Sometimes there's more than just a few options, and sometimes there's even more than that. In the case of my audit, we had a ton of radio inputs being conditionally injected into the page. And the point of this being is this all adds up. Google's Lighthouse project, an open source tool that analyzes your website for performance problems, recommends that an optimal website DOM tree has the following. Less than 1,500 nodes, a max depth of 32 nodes, and no parent node with more than 60 child nodes. What I'd like to call attention to here is the max depth of 32 nodes bit. That might seem like a lot of wiggle room at first, but if you take a moment to think about the websites that you've worked on and their templates, there's the frame set, there's wrapper divs, there's component wrappers, and if you're doing it right, you have field sets for your forms, each digging a little bit more inward. Another part of accessibility auditing is providing a fix to the problems you uncover. It's tough work, but nobody likes to pay people money to tell them all the things that are wrong with them and then offer no solutions. So we wound up recommending a radio input pattern that utilized 3 HTML elements. It's a pattern developed by my friend Scott. Wow, look at that go. Taken from his excellent A11Y styled form controls project. It's worth saying that Scott puts these patterns through their paces and tests them with an incredibly robust set of assistive technologies. So a nice side benefit to knowing about this is knowing I can recommend them with confidence. Visually, it was completely indistinguishable from the original version. And to compare the two solutions, we had a 50% reduction in HTML elements, and we cut the DOM depth down by 1/3. There's also a 30% reduction in CSS selectors and properties, resulting in the CSS payload for this pattern being reduced by 90%. We've also completely removed 30K of JavaScript, which is 30K less blocking resource being served. And cobbling up a rough prototype, we were able to create an environment that mimicked the conditions of the site we were auditing. And we're using the new radio input code, and guess what? It worked. VoiceOver didn't crash. So why is this our problem? Why should we care about the fragility of other people's software? Well, prioritizing developer ergonomics without considering the generated HTML can lead to bad things happening. And regardless of our setup, we tend to pile even more things onto our base experience. Things like ads and analytics and social marketing engagement tools and development integration utilities. And then there's also the Cold War raging between websites and their users. Here's Facebook splitting up a single word into 11 DOM elements to avoid ad blockers. And this graph is generated from the median values of how 1.3 million websites are generated, with JavaScript claiming the majority of the share. This JavaScript majority means that it's that much more time spent blocking the browser from performing other actions, including things like interfacing with assistive technology. When we throw out what the browser gives us for free, we oftentimes don't realize that there are very real, very important things we sacrifice in doing so. Here's what Marco Zahi, Mozilla's senior accessibility QA engineer, has to say about this. Emphasis on the underlines mine. Nibbling away at those milliseconds it takes for information to reach assistive technologies when requested. My current task is to reduce the number of accessible objects we create for HTML div elements. This is to reduce the size of the accessibility tree. This reduces the amount of data being transferred across process boundaries. Part of what makes Firefox accessibility slower on Windows since Firefox Quantum is the fact that assistive technologies now no longer have direct access to the original accessible tree of the document. A lot of it needs to be fetched across a process boundary. So the amount of data that needs to be fetched actually matters a lot now. Reducing that by filtering out objects we don't need is a good way to reduce the time it takes for information to reach assistive technologies. This is particularly true in dynamically updating environments like Gmail, Twitter, or Mastodon. My current patch, slated to land early in the Firefox 67 cycle, it's already landed, shaves off about 10 to 20% of the time it takes for certain calls to return. Note that all this optimization is only for one browser, Firefox. And there are a lot of browsers out there. It's also not all about browsers either. This is a refreshable Braille display, one of the many other kinds of assistive technology that interfaces with the accessibility tree. So someone should do something, the battle cry of bystanders everywhere. Let's unpack this some and figure out our available options. For screen readers, the main ones are JAWS and NVDA. Both are Windows screen readers. VoiceOver for macOS and iOS, and TalkBack for Android. These are the big four screen readers you're going to hear about, and it's sort of analogous to Chrome, Safari, Firefox, and IE in that there's more screen readers out there, but these cover the main use cases you're likely going to deal with. And while not all assistive technology are screen readers, if your site works well with them, chances are good it'll work well with other assistive tech. Of them, all but one have an open issue tracker, but half have closed source code. This means that while we can file issues, we aren't really empowered to do much more about it on the assistive technology layer. It's also completely unrealistic to expect people to submit and follow issues or code pull requests across all trackers in addition to working a full-time job. So our only other realistic option is to keep the DOM trees on our sites nice and shallow. And there are actual tangible benefits to doing this. Here's Marco again weighing in on his optimization efforts, and he says that reducing the number of milliseconds it takes for a screen reader to start speaking after a key press from about 140 to 100 here, or from a 120 to 100 there, doesn't matter much on a fast machine. On a slow machine, that reduction is about 230 to 250 down to 200 or 190. So let's talk about what a slow machine means. If you are disabled and or underserved, you face significant barriers to entering and staying into the workforce. This means you have less access to current technology, especially the more expensive, higher quality versions of it. Another factor is some people who rely on assistive technology are reluctant to upgrade it for a very justified fear of breaking the way they used to interact with the world. Slow machines may also mean an ancient computer. Inexpensive Android smartphone tablets are a common entry point for emerging markets, and with Android comes TalkBack. A slow machine might also come from a place you may not be expecting, by which I mean you might have a state-of-the-art computer, and because of that you're doing state-of-the-art things on it. This requires a ton of computational resources, which makes fast things slow. With less computational resources to go around, we may have unintended consequences, possibly recreating a situation similar to our too many radio inputs problem. I'd like you all to think about Electron apps, which are desktop programs that are built with web technologies. So accessibility auditing isn't something people normally do out of the goodness of their own heart. It's typically performed after a lawsuit has been levied against an organization. And let me be clear here. When you create inaccessible experiences, you are denying people their civil rights. The Americans with Disabilities Act guarantees that people cannot be discriminated against based on their disability conditions. And this extends to both private organizations and the digital space. And this is a good thing. This guarantees protections as more and more of the services necessary to living everyday life go online. You need to work with what you have and not what you hope will be. Part of this means understanding that when we want things to be better, we need to understand that these kinds of changes are really technically complicated under the hood and spread across multiple concerns. On top of that, accessibility fixes are often viewed as unglamorous and therefore deprioritized compared to other features. And if you don't believe me, here's the support matrix for the title attribute incorporated into W3C's HTML spec in 1993. It's 26 years later, and we still have a ton of interoperability problems. I don't mean to bum you out, and I don't expect you all to become accessibility experts. However, as people who are interested in more than just the surface level of things, you are all uniquely empowered to affect positive change. What I ask of you is to at least incorporate basic accessibility testing into your workflows. And if anything, just check to see if a screen reader crashes. After all, like a bad assistive technology experience is still better than none at all. Okay, whoa, the slide background is yellow now. This is what we call a great segue. It landed. I'm a designer by trade, and part of that job means coming up with alternate strategies for allowing people to accomplish their goals, because sometimes the most effective solution isn't necessarily the most obvious one. With that in mind, we're going to talk about another definition of performance, which is the ability to actually accomplish something. All these little surgical tweaks and optimizations don't mean squat if people don't understand how to operate the really fast thing that you gave them. Another aspect of dynamically injecting a ton of radio inputs into a page is that it adds more things for a person to think about. This is called cognitive load, and it's a huge problem. It affects our ability to accomplish tasks, and importantly, accomplish these tasks accurately. Namely, it inhibits our memory and our problem-solving skills, our attention spans, our reading comprehension level, our math comprehension level, and shockingly, our ability to actually understand what we see. It's such an important problem that NASA developed the Task Load Index, which is an assessment tool to help quantify it. And these aren't warm, fuzzy feelings about empathy. This is a serious attempt by a government agency to refine efficiencies and reduce errors. And one of the most important and interesting things about the existence of the index is that it's an admission that disability conditions can be conditional. Think about it. Like, when's the last time you were tired or distracted or sick or learning a new skill or a combination of all the above? Or, heck, when's the last time you were drunk and trying to use your smartphone? Cognitive load is an important thing for building rockets, sure, but it also translates to other complicated things like making and using software. One of the things we can do to lessen cognitive load is to lessen the amount of information someone has to parse at any given moment. For the medical education app, we could have added an additional step to the user flow that asks a high-level segmenting question. It's a little more friction, sure, but it's being used strategically as a focus choice to keep the cognitive load lower. This would help filter down the results you get, which makes it both easier for a person and for the browser to parse. And the other big picture question we need to ask is all of this even necessary? The most performant pages are the ones you never have to use, by which I mean how often can we sidestep these issues by using other resources and information made available to us? If you're interested in this sort of thing, the 2018 Design and Tech Report is a must-read piece. One of the things it was revealed is that surprisingly very few companies conduct qualitative user research, which is the practice of asking people how they'd use a feature and how they feel while they do it. So that's 12% for early stage startups conducting qualitative user research, 32% for mid-stage startups, and 46% for large. And I'm not really a numbers person, but there does kind of seem to be a trend going on here. And another interesting thing is barely any companies conduct qualitative user testing for features after launching them. So we're all just developing features and throwing them into the larger, ever-evolving ecosystem that is your product and not seeing how it'll actually affect things. We also need to remember that we're only seeing those companies that beat the odds. The The market is built on top of the corpses of failed businesses who poured all their cash and all their time and all their resources into the wrong features. The second big ask from this talk is really just me repeating the first one. It's one thing to read about something and believe it to be true, but it's another thing entirely to put it out into the world without verifying that it works. The web, and more importantly, the people who use it, are too important not to. So I just want to say thank you to our captioner and to Michelle and the other staff, Mina for being a great MC, Estelle for organizing such a wonderful conference, and most importantly, thank you to all y'all, the audience. The slides for this talk are available online on Noticed, and I'll be both tweeting out a link and linking to it on my personal website. This also includes resources that you can go and read if you're so inclined. Thank you.